Hey again, guys. It's our second set of notes and our second sort of topic for this week. We're still going to be working with rectangles, and I think you're going to find that this is actually a little bit easier than even perimeter. So today we're going to be talking about area of rectangles. So we're still working with the shape rectangles. Today we're just going to be talking about area. Now we talked about area of a circle, and if you remember the area of a circle, I'm just going to make a little tiny note off here to the side. The area of a circle was how many square units it would take to cover up the circle. It was the inside space, if you'll remember, like all of this stuff. And so for a rectangle, it's really no different. We're going to be looking at a rectangle today. And we're going to ask ourselves, how much space is on the inside? In other words, if I were to draw in little tiny squares into my rectangle, how many of those squares would it take in order to fill up all of that inside space? So the definition of area, again, whether it's for a circle or for a rectangle, today we're just going to be dealing with rectangles. Area is the number of square units it takes to fill the inside of a shape. In our case today, we're just going to be dealing with rectangles. So let's look at an example. If I give you a rectangle, and it looks something like this. And I ask you, what is the area of this rectangle? Maybe I don't know, maybe we're painting the top of a rectangular table, y'all, or maybe we're covering the side of some rectangular shape with construction paper or with wrapping paper. We just want to cover something. Then first we're going to look at, well, what is my length and what is my width? We want to know how many of these squares it takes. Well, if you notice, this side is 1, 2, 3, 4, 5 squares long, and it's 3 squares wide. Now, one thing I could do is I could just count. How many squares does it take to fill up the shape? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the area of this rectangle is 15 units squared. Remember, for area, we always put that 2 up there at the top. We don't know whether these are inches or feet or centimeters or anything, so I'm just going to put units. But there is a much quicker way of figuring out area rather than just counting, although counting is totally fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Can you think of a way that we could have done that a lot quicker? Well, if I know that this is my length, or I know that this is my width, what I can do is I can simply multiply these two numbers together, right? So if I want to find my area, A, what I could have done was just done 5 times 3, and that gives me 15. And so in general, my formula for finding the area, or the number of square units inside of a figure, is going to be to take my length and multiply it by my width. Sometimes you'll see it written like this, just L times W. Remember, we write the curly L so it doesn't look like a 1, but it's always going to be the length times the width of a shape. So let's look at an example of what that might look like. So we'll call this example number 1. Let's say you're given a rectangle. Let's make it a longer and skinnier one. And let's say that this rectangle has a side length of 11. Let's say that that's centimeters. And let's say that you're given that it has a width of 5 centimeters. Now, again, it does not matter whether I call this the length or this the width, or this the length and this the width. You can switch them interchangeably. And so the first thing I'm going to do, if I'm looking to find the area, what is the area, meaning what's the space in the inside? Notice on this one I do not have the squares. Now, I could draw them in if I wanted to, 11 this way and 5 this way. But it's much quicker to use our formula. And area is equal to the length times the width. All I've got to do is decide what's my length and my width. Again, doesn't matter, but I'm going to label this is my length, this is my width. Area is equal to 11 times 5. Area is equal to, grab your calculator if you need to. Hopefully you know your 11s though, and that 11 times 5 is 55. If not, type it in. 11 times 5, 55. Now, my units are centimeters, so it's going to be centimeters, and remember this is area, so it's always going to have that little squared 2 in the top because I'm multiplying unit by unit. So the area is 55 centimeters, and that is all there is to finding area, multiplying length times the width. So let's look at example number 2. Let's do another one with the formula. So let's say that we're given a rectangle, and let's say that we're told that this side is 10.5 miles, and let's say that we're told that this side is 12.3 miles. Alright, and we're told we want to find the area. So write down your formula first. Area is always equal to length times width. Area is going to be equal to, so again, define which one's your length and width. It does not matter. You can call this the length, you can call this the length, you can call this the width, you can call this the width. In this case, I'm going to call this the length. And if you want to keep it consistent, maybe calling the top one, that's fine. But I'm going to label my L, my W. I'm going to plug in my number, so my length is 12.3 times 10.5. Area is equal to, grab your calculator, especially because these are decimals, so I'm going to type in 12.3 times 10.5. Hit equals, and so your area here is 129.15, and my units here are miles, and remember we always want to put that squared at the end. Miles squared. So if I drew in all of my little squares in here, draw 10.5 lines, and I draw 12.3 units, then it's going to be 129 squares and 1/1500ths of another square that would cover this. And so that is how you find area. Now, you also are going to be given a word problem, or a couple word problems in the practice. I'm going to flip over to the next page so I'll have enough room. So let's call this example number 3, and maybe you're given a word problem that sounds something like this. Let's say Susan, don't ask me who Susan is, no idea. Susan is putting topsoil onto her garden. Now, if you don't know what topsoil is, sometimes if you plow a garden and you want to put down some really good dirt on top of it, you know, there's dirt already there, but if we want to put down really good dirt, we call that topsoil. It's the good dirt we put on top. Susan is putting topsoil onto her garden. Her garden measures 105 feet in length and 50.2 feet in width. How much topsoil will it take to cover her garden? Now, that word cover right there, that automatically tells you I'm concerned about the inside of this garden. So, when you're given a word problem, of course, draw your picture first. I'm going to draw my garden here because it tells me that it's got a length and a width. The garden is usually in a rectangular shape. It says that it measures 105 feet, so I'm going to label that 105 feet in length. They tell us that that is the length. And the side here is going to be 50.2 feet, and that's going to be my width. I'm going to label that with W. And so the question is, how much soil will it take to cover the garden? So I'm putting soil all over this garden. All of the inside is what I'm trying to cover. And so that's going to be area. So write down your formula. Area is equal to length times width. And I'm going to plug in my numbers. Area is equal to length, which is 105, times your width, which is 50.2. Multiply those numbers together. We've got 105 times 50.2. Hit equals, and the amount of mulch that it's going to take is going to be area equal to 527.1. My unit is feet, and that is square. Side note, forgive me, I don't know why I put this decimal here. It should be 5 1,271 feet squared. My apologies. And so that is how you find area using this formula.